Okay? So we're talking about the carbohydrates, metabolic process. As a recap, I discussed in the first topic of carbohydrate metabolism, working diet carbohydrates. Diba? The first rate limiting metabolism or digestion, of course, is about because of the presence, example, of the amylase enzyme. Amylase enzyme is an enzyme that we're going to hydrolyze your polysaccharide, example, starch. Then follow the digestion process that takes place in the stomach. Okay? And after that one, digestion process, example, polysaccharide are converted to a disaccharide. Then it will go to the small intestine, and in the border of that small intestine, there are also of the enzymes that will hydrolyze the disaccharides to monosaccharides. Example of disaccharide is sucrose, maltose, lactose. Sucrose is hydrolyzed by sucrase. Your maltose will be hydrolyzed by maltase enzyme. Lactose will be hydrolyzed by lactase. Example, lactose is converted to glucose plus galactose. After that one, it will now cross the epithelial tissues of the lumen or the intestine to the bloodstream by facilitated diffusion process. So facilitated diffusion process is a transport mechanism wherein the movement of your galactose and glucose are sodium dependent, right? And fructose is not sodium dependent. They are facilitated by, they are transported by facilitated diffusion process. And it follows the uniform system. It's a uniform, the movement that biomolecules to mga monosaccharides are in one direction. Then it enters the blood. In the blood, they know by their students, we discuss also that the movement or the uptake of the, what call this one? Of the glucose, for example, the glucose or your carbohydrates, example, this is your cell, is considered to be insulin dependent. Usually, insulin binds to the receptor or beta sub receptor units. So, this is your beta receptor, for example. This is cell membrane. Okay? So, this is your glucose. Then, binding of insulin to the beta receptor subunit will activate the RS, the insulin receptor subunits, and then we have also the PIP, or the protein phosphatidylate principle 3 kinase enzyme. That will lead to series of or cascades of events that will translate your glucose or GLP or glucose transporter for the cell membrane. Okay? So your glucose GLP-4 is the one that will transport your glucose from the blood up to the tissue. So after that one, it follows the glycolysis process. That is the pathway of the movement of the carbohydrates until it reaches the tissue. So, in the tissue, there's now what we call glycolysis process. So, what is the purpose of glycolysis? The purpose of glycolysis is this molecules to produce energy in the form of ATP. Okay, there's a consumption of energy, especially in the first stage. Glucose is converted to glucose 6-phosphate by hexokinase enzyme. So, there's already the addition of phosphate group to the glucose at the position carbon number 6. Like say, glucose to glucose 6-phosphate. So take note the enzyme hexokinase. Then glucose to fructose 6-phosphate is the phosphoisols isomerase. The reaction is isomerize. Glucose 6-phosphate is isomerized to fructose 6-phosphate. Kasi glucose 6-phosphate, isomer mo na siya dua. Parehas na siya dua. Okay? Diba? Then, yung fructose 6-phosphate is phosphorylated to fructose 1,6-bisphosphate by phosphoproctokinase enzyme until it reaches now the stage 4 or step number 4, where your fructose 1,6-bisphosphate is separated to dihydroxyacetone to diacetylphosphate. Kasi yung step 4 is the splitting phase. Remember. Then, yung glyceraldehyde is converted to 1,2-bisphosphoglycerate to 3-phosphoglycerate to 2-phosphoglycerate to phosphoglycerate until it reaches the pyruvate. So yung pyruvate is known to be the final product of glycolysis. This pyruvate is used again in the process of gluconeogenesis. Meaning, yung gluconeogenesis is the opposite of your glycolysis. Anong final product ng gluconeogenesis? Glucose. So, tandaan nyo na enzyme product steps. Okay? So, there are questions and questions also coming from the pathway. Okay? Next, we go down to pentose phosphate pathway. Ano yung pentose phosphate pathway? The glucose 6-phosphate, where can you found glucose 6-phosphate? The glucose 6-phosphate is the byproduct of step number 1. You remember step number 1? Diba? Glucose. Your glucose is your glucose, right? Glucose. Glucose is converted to glucose 6-phosphate. So this is your carbon number 1, 2, 3, 4, 5, 6. So glucose is converted to glucose 6-phosphate. Diba? Tama mo na. Glucose 6-phosphate. Glucose 6-phosphate. Tatlo ito, apat. Glucose 6-phosphate. Okay? So glucose 6-phosphate is 1, number 1, 2, 3, 4, 5, 6. So yung glucose 6-phosphate, in pentose pathway, there are two processes. Yung oxidative and non-oxidative. Mamang non-oxidative, use up oxygen. Okay? So, this one, in a glucose, in the pentose phosphate pathway, your glucose 6-phosphate is converted to a 5-carbon atom known as ribose 5-phosphate. Okay? Ribose 5-phosphate. Ribose, ayaw pagbilang na ribose 5-phosphate. Ito si ribose. Yan. Ribose 5-phosphate. Yan. Ribose 5-phosphate to ribose 5-phosphate. Sa ribose is considered to be a ketose. Tatawag ng number 2. Ketose kasi yan. Ito yung phosphate group. This is the start training. Ito naman yung oxygen mo. Okay, i-add sa PO3. Okay, phosphate PO3. Okay? So, in pentose phosphate, yung glucose 6-phosphate mo is converted to a 5-carbon atom. Okay? Okay? 5-carbon atom. This is your ribose phosphate. So this one is going to be pentose phosphate pathway. Okay? That is another pathway. Okay? So ano na ito ang pagkakalawan natin pentose phosphate pathway? So, in pentose phosphate pathway, that has the functions of your NADP. What is the NADP? Nicotinamide adenine dinucleotide is known to be the reducing agent. Reducing na siya or oxidizing agent. It removes hydrogen, for example, in the hydrogenase process. So, maybe siya functions for cholesterol synthesis. Meaning yung cholesterol is being synthesized via pentose pathway. Fatty acid synthesis also. It's also synthesized or produced from this pentose pathway. And your reduction of glutathione protects from tinatawagan natin mga reactive oxygenated radicals. Okay? Ito mga ROS, reactive oxygen, oxygens. Tawag ko mga radicals yan. Yan ang reduction of glutathione. Because the glutathione is considered to be used in conjugation reaction. Okay? So, glucose 6-phosphate, which is the second product, the first product of glycolysis process, right? Remember nyo? Is converted to 6-phosphogluconate. It's considered to be the rate-limiting step. So, yung process dyan is, ano process? Glucose 6-phosphate to 6-phosphogluconate. Dehydrogenation, removal of hydrogen. Basta dehydrogenation. Removal of hydrogen, that is oxidation process. Glucose 6-phosphate dehydrogenase enzyme involved in the conversion of your glucose 6-phosphate to 6-phosphogluconate. Oxidative reaction. Meaning, oxygen. Diba? May kistis pa. Next, your 6-phosphogluconate is converted again to ribulose 5-phosphate or NADP is converted to NADPH. So rather, removal of hydrogen, oxidation process, dehydrogenase. Kung sa dehydrogenase galing, removal of hydrogen, that is oxidation. Kung nag-add ka ng hydrogen, nag-add ka ng hydrogen, that is, ito ng hydrogen, reduction process. Paano? Basta nag-remove ka ng hydrogen, automatically, oxidation process yan. That's why 6-phosphogluconate dehydrogenase enzyme convert 6-phosphogluconate to ribulose 5-phosphate. Then, yung ribulose 5-phosphate nyo, di ba, kanina, ribulose 5-phosphate is converted to ribulose 5-phosphate by ribulose 5-phosphate isomerase. Isomerase na, dito na-shortcut tayo. Meron pa sa isang step, yung ribulose 5-phosphate to ribulose 5-phosphate. Di ba isomerase? Isomerase ng dalawa. Si ribulose 5-phosphate at si ribulose phosphate. Isomerase na. Ano nila ginagawa? Yung urban, fructose na ka. Fructose ka. Glucose. Sino na asawa ka? Dito na sa kalahin sa babaw. Di ba? Bangkok versus your phosphate ito. Ribulose 5-phosphate. Okay, so isomerize. This is your ribulose phosphate, then your 5-ribose phosphate. Sorry, 6. 5. 6 na ako. 5 is already. 1, 2, 3, 4, 5. Ribose spike carbon atom. Ribose spike carbon atom. Okay? Okay, class? Is that clear, guys? So, only way I can help you. Sana naman masalahan. Okay, bahala na ito ba dyan? Pumunta. Okay? Next, we have oxidative ring na. Diba? Sa taas niya na. Yan ay oxidative. Why oxidative? Why oxidative? Kasi nag-remove siya ng hydrogen. Tandaan nyo, oxidative siya kasi nag-remove siya ng hydrogen. Okay? Kasi pag remove ng hydrogen yan, oxygen na yan. Okay? Next. Dito tayo. So we have your oxidative, then we have your non-oxidative pathway. Okay? So, 5-ribose phosphate, tandaan nyo, it is converted to glucose 6-phosphate. Anyway, yung non-oxidative is a reverse only of your oxidative. Tama na ba? Si 5-ribose phosphate, right? Babalik siya kay 6-glucose phosphate. Okay? But before siya magbalik, before your 5-ribose phosphate goes back to glucose 6-phosphate, kaya sa 5-ribose phosphate is converted to 7-hydrolose 7-phosphate by trans-ketorase enzyme. Tandaan mo na enzyme. Then your 7-hydrolose 7-phosphate is converted to fructose 6-phosphate by trans-aldolase enzyme. Then it produces glucose 6-phosphate. Then your fructose 6-phosphate is isomerized to glucose 6-phosphate. This one, non-oxidative, meaning walang oxidation process po. Tandaan nyo, yung dalawang process ng 10-phosphate pathway. We have the oxidative and non-oxidative. Pag oxidative siya, post back sa'yo, yan, oxidative yan, hanggang dito. Okay? Pag abobrate, babalik yan. Non-oxidative from ribose phosphate to glucose 6-phosphate. Kasi continuous dito, this is already glycolysis. Once na-convert sa fructose 6-phosphate, diretso na yan sa glycolysis process. Pero sabihin natin non-oxidative, reversible na yan. Pwede siya magbalik. Okay? That's why, try to see our diagram in oxidative versus non-oxidative. Your non-oxidative is the reverse. So, pwede magkaroon na yung ribose 5-phosphate mo, pwede siya maging ephemerized to xylulose 5-phosphate. That's another pathway. That is reversible process. Okay, ito, reversible process. Same enzyme. So, pwede si xylulose is converted to phosphate, transferase yapon, to electrose 5-phosphate unbinding is formed into fructose 6-phosphate by transferase enzyme. So, pares-parehas na siya. Okay? This is another pathway to ephemerise na. When you ephemerise, your 5-ribose 5-phosphate is ephemerized to xylulose 5-phosphate. Okay? Meaning dito sa 5-carbon, hindi na siya mag-pwede siya. So, until babalik sa fructose 6-phosphate. Kung fructose 6-phosphate, glucose 6-phosphate, pwede ma-reverse. Okay? So, another pathway, yung electrose 4-phosphate mo, pwede siya ma-convert to glyceride phosphate from xylulose, xylulose ito. Pwede siya mag-diretso din. Then, go back to fructose 6-phosphate. Fructose 6-phosphate, I mean. Okay, again ha. Ribose, pwede siya i-convert dahil itong glucose 6-phosphate. Bakit sa kay 7-hydroxylose 7-phosphate to fructose 6-phosphate to glucose 6-phosphate. Or ribose 5-phosphate is phenolized to xylulose 5-phosphate to glycerol-phosphate, retrose phosphate, then pwede siya kapalagay fructose 6-phosphate to glucose 6-phosphate. Kasi si glucose 6-phosphate, tandaan nyo, that is a intermediate product for glycolysis. Or yung xylulose 5-phosphate mo directly converted to glycerol-phosphate babalik sa fructose 6-phosphate. Okay? That's why ang oxygen ang non-oxidative is the reversible reaction. Okay? May question din si Jan sa Pentecostal pathway. Anyway, I will review the PowerPoint. Next, we go down to tricarboxylic acid cycle or acetic acid cycle. This involves 8 enzymes essential to production of aerobic respiration and glycolysis around early evolution. Meaning, this cycle is very important in the glycolysis process naman. Okay? So the pathway is also important in gluconeogenesis and amino acid biosynthesis and fatty acid biosynthesis. Okay? Take note. So, citric acid cycle usually takes place in the mitochondria of eukaryotic cells and in prokaryotes in cytoplasm. Mga prokaryotes ito yung saan po ng prokaryotes? Prokaryotes. Malita na. Ano yung saan po ng prokaryotic cells? Bacterial cells. Prokaryotes are bacterial cells. Diba? Eukaryotic cells. Ito yung usually the animal cells we are in the eukaryotic cells. Okay? The pyruvate formed in the cytoplasm from glycolysis. Pyruvate. Where does pyruvate came from? Saan guys pyruvate? Is nila Korea. Sila sel na. Yung sayo. Hindi naman si pyruvate. Product of glycolysis. Is brought into the mitochondria where further reactions takes place. Mintanan nyo, ang ato na pagkakasunog. The final product of glycolysis is pyruvate, which is also utilized in gluconeogenesis process. Correct? Okay? But in Pentos pathway, it does not utilize that pyruvate. Ano yung utilize sa Pentos pathway? Hindi. Utilize niya na the glucose 6-phosphate. Glucose 6-phosphate to ribose 5-phosphate. Okay, balik naman na siya dito, that is non-oxidative. Okay, glucose 6-phosphate to ribose, that is oxidative. Okay, now, we are now in the tricarboxylic acid pathway. So, tricarboxylic acid pathway, my dear students, yung pyruvate came from the glycolysis will be utilized in the mitochondria and brought into mitochondria where there is a further reactions that happens. Okay? The different enzyme involved in citric acid cycle usually located at the inner membrane or in the matrix of the space mitochondria. Kasi mitochondria mayroong inner membrane. Correct? Mayroon siyang tinatawag na matrix. Ano din nandun sa mitochondria? What is the main function of mitochondria? Production of energy that is known to be the powerhouse of the cell. Powerhouse. A girl power. Okay. Next. So, tandaan nyo, fatty acids are oxidized to acetyl coenzyme A and enters the citric acid cycle. So, take note, yung fatty acids, what is the main function? What's the function of fatty acid? It provides energy. So, paano siya nagkaroon ng energy? So, i-oxidize ko na sa acetyl coenzyme A, then enters the citric acid cycle to produce energy kasi dito nag-produce rin ng energy. Paano? Related yan. Take note, fatty acids are oxidized in acetyl-CoA and it is utilized in citric acid to produce energy. Kasi ang functions ng fatty acid is also to give energy. It's a fuel of our body. Okay? Okay? Next, citric acid cycle occurs in the mitochondria. So there is NADH, and we have the NADH produces responsible for producing ATP. Okay, tandaan nyo yung NADH, ano sa NADH? It is your nicotinamide, adenine, dinucleotide plus hydrogen. So, kung plus hydrogen, anong function niya? Dehydrogenation. Plus hydrogen. Basta may plus hydrogen, plus hydrogen. And you have your NADH known as your adenine, dinucleotide. This is another oxidizing agent. Basta may NADH plus H na sa gamit, hindi nagkakuha kasi sa hydrogen. Okay? So, the electric transfer chain ATAC is a process in which NADH and NADH produce during glycolysis process. Electron transfer chain, once ng oxidation process, electrons are being transferred. Delta oxidation and metabolic processes are oxidized as they release energy. That is why your fats are also utilized. Okay? So, hindi na siya fatty acids, don't siya na acetyl-CoA. Okay? Ito, kung saan may arap na naka-highlight. Okay? Naka-highlight. Anyway, I will give the PowerPoint diagram para kumain. Okay? Sabi sa natin sa Biochem. Tuesday, Wednesday. Thursday. Last day. At least we have almost... Ano? Last ka? On Thursday, exam. Okay lang. You have almost 3 days to prepare. Or 5 days. So, in eukaryotic cells, enzyme that catalyze the actual citric acid cycle matrix, except for succinate dehydrogenase, which are present in mitochondrial membrane. Meaning, lahat ng enzymes na involved in citric acid cycle usually found in the matrix, except the two. Dehydrogenase and aconitase are present in the inner membrane. Okay? Another enzyme, we have 8 cyclic synthase, aconitase, isocyclic dehydrogenase. So, aconitase, and isocyclic dehydrogenase nasa inner membrane. Okay? The rest sa matrix na mitochondria. Okay? Alpha-ketoglutarate, succinyl coenzyme synthetase, succinate dehydrogenase, fumarase, malate, and malate dehydrogenase, are in the matrix. Except ito. Tandaan nyo ito sa matrix, sa inner membrane. The rest, the CASSFM, CA-alpha, CASS, ito sa matrix. Okay? So, AI sa inner membrane. Okay? Yan yung mga enzymes, 8 steps is yung PCA cycle. Okay? So, ano yung mga cycle na yan? Okay? So, we have citric acid cycle. The pyruvate Saan galing si pyruvate? Glycolysis, the final product of glycolysis. So si pyruvate ka naman, take note my dear students, yun ang i-utilize in the process of PCA cycle, the Krebs cycle. What is the purpose of Krebs cycle? What is the main purpose of this one? To produce energy in the form of ATP pa rin. Okay? To produce energy in the form of ATP. Okay? So pyruvate to acetyl coenzyme A. Okay? Yun yung initial steps. So we go with the step number steps, the pre-step. Okay? Or the step number 1. Itong pre-initial steps before the step number 1. Okay? After the glycolysis process, you have to remember the product na pyruvate. Okay? The pyruvate molecules are decarboxylated. Okay? Pyruvate. It is pyruvate, no? Diba? Pyruvate is COCH3. This is the pyruvate. Where does pyruvate came from? Saan galing si pyruvate? This is the product of the glycolysis process. Okay? Before the steps in PCA cycle began, si pyruvate will be decarboxylated to form acetyl coenzyme A. This is going to be a pre-step before the step number 1 of PCA cycle. Okay? Your pyruvate is converted to acetyl coenzyme A. Acetyl coenzyme A siya. So this is your acetyl coenzyme A. Coenzyme A. Okay? So, what is the process? The oxidative decarboxylation of pyruvate forms a link between glycolysis and citric acid cycle. Meaning, once nagkaroon ng decarboxylation, there is already a linkage of citric acid cycle and glycolysis. Why man? Siyempre nag-form na sa acetyl coenzyme A, yung galing ng acetyl coenzyme A sa pyruvate, meaning link na yung nag-link na si pyruvate and glycolysis. Because yung byproduct ng glycolysis mo, final product, yun ang naging dito sa Krebs cycle. That's why that is a linkage. Okay? Next, in this process, pyruvate derived from glycolysis is decarboxylated to form acetyl coenzyme A. So there is what we call dehydrogenation process. So pyruvate dehydrogenase enzyme is involved in the conversion of pyruvate to acetyl coenzyme A. Okay, ito, ang galing, addition ng acetyl coenzyme A. This is your coenzyme. So yung NAD mo is converted to NADH. That is dehydrogenation process. Dehydrogenation meaning that is oxidation. Okay? We have your complex enzyme 1 and enzyme 2 is a process of doing that. Importante na natin. Okay? Next. Take note, acetyl coenzyme A, the pyruvate oxidation, fatty acid oxidation, and amino acid oxidation. So, yung acetyl coenzyme A, saan galing yan? Galing sa pyruvate oxidation, galing sa fatty acid metabolism or amino acid metabolism. Okay? Si acetyl coenzyme A came from, tandaan nyo na, came from fatty acid, came from pyruvate oxidation, and AA metabolism. Amino acid metabolism. Okay? So we go now to step number 1. Kasi tayo. Oras na. Okay? Step number 1. Condensation of acetyl coenzyme with oxaloacetate. So step number 1. there is a 4 carbon oxaloacetate and 2 carbon acetyl coenzyme A condensation. Meaning, in step number 1, si acetyl coenzyme A mo, which is the product of the pre-step, yung pre-step natin, yung si pyruvate is converted to acetyl coenzyme A. So, si acetyl coenzyme A mo, in step number 1, combine with the, combine oxaloacetate, forming now citrate. Citrate is 1, 2, 3, 4, 5. Okay? 5 carbon atom. Kasi si acetyl coenzyme yung 2 carbon atom lang. 1, 2. Oxaloacetate, 1, 2, 3, 4. Pag-combine mo lang, 1, 2, 3, 4, 5. That is considered to be your citrate. Okay? What's the enzyme? Citrate synthase. So, citrate synthase found in matrix. Matrix, apologies na mag-dehydrogenase ng bunyara sa inner membrane. Okay? Next. Step number 2. So, your citrate is, okay, happens in the mitochondria. So, we learn now the third step. Sa third step, yung isocitrate mo is converted to alpha-ketoglutarate by oxidative dehydrogenation process. Okay? Step number 3. Right ito, si isocitrate, to make it clear, is converted to alpha-ketoglutarate by enzyme isocitrate dehydrogenase. But before magkaroon na alpha-ketoglutarate, syempre, there is a series of steps. Okay? This reaction, likewise, second reaction is a two-step reaction. The first step, isocitrate is dehydrogenated to oxaloacetate. Kagad basa, before mag-form siya ng alpha-ketoglutarate, si isocitrate, take note, is dehydrogenated, meaning there is removal of hydrogen. That is why your NADP is converted to NADP plus 2 hydrogen. Kasi tinipon dito hydrogen, no? Okay? Nakuha yan? Forming oxaloacetate. Then your oxaloacetate is decarboxylated. There is what we call withdrawal of electrons. Why? Because carboxyl group is 2 oxygen, oxaloacetate is catalyzed by your enzyme isocitrate dehydrogenase to alpha-ketoglutarate. Ano hindi siya dahil? Okay? So there is just rearrangement of the enol intermediate generates ketoglutarate. Rearrangement lang ito. Itong enol, remember enol? I explained about enol. Sa klase na explain about enol. Itong enol, no? Okay? Rearrange lang to form alpha-ketoglutarate. Anong enzymes dito? Isocitrate dehydrogenase. Okay? Same enzyme na siya. Okay? Next. Who's that girl? Coming here. Okay? Oh. Tandaan sa nine. Miss, Okay? Yeah, Mrs. Delan. Okay? Then, step number 4. Step number 4, the product of your step number 3, ano kanina? Alpha-ketoglutarate. Okay? This step is another oxidation reduction process. Okay? Where alpha-ketoglutarate is oxidatively decarboxylated to form 4-carbon-succinyl coenzyme A. Okay? Decarboxylated. So, kung decarboxylated, what functional group is being removed? What functional group? COO.
decarboxylated. Diba? Enzyme is known to be, decarboxylates. Diba? So, alpha ketobutyrate is converted to succinyl coenzyme A by the enzyme alpha ketobutyrate dehydrogenase complex. Dehydrogenase complex. So, tandaan lang, enzyme product. Okay? This reaction is similar to oxidation, decarboxylation of pyruvate involved the reduction of your NAD into NADH. Reduction siya. Why? NAD man ito to NADH. Okay? Next, step number 5. Step number 5, conversion of your succinyl coenzyme A, which is the product of your step number 4, to succinyl. So, the next step, succinyl coenzyme A undergoes energy conserving reaction in which succinyl coenzyme is cleaved to form succinate. Okay? This reaction is accompanied by phosphorylation of guanosine diphosphate to guanosine triphosphate, meaning yung source ng phosphate group is not an ADP. Okay? It is the GDP. So there is a gain siya. Kasi kung loss siya, triphosphate to diphosphate. Ini guanosine diphosphate to guanosine triphosphate, meaning there's a gain of 1 electrons. That is already energy production. Take note, in step number 5, the source of a phosphate group is not ATP. It's the GDP, guanosine diphosphate to guanosine triphosphate. So what is the product? Succinate. Okay? Yung coenzyme A mo is being released. Succinyl coenzyme A synthetase. So, succinyl coenzyme A is converted to succinate by succinyl coenzyme A, and there is what we call the conversion of your GDP to GDP, and electrons are being gained. Okay? Next, step number 6, dehydration of your succinate, meaning water is being removed in your succinate, H2O. Okay? So, succinate is converted to fumarate by dehydrogenation process because it's acted by succinate dehydrogenase enzyme. So, FAD to FADH. This is your oxidizing agent. Di ba may dalawa tayong oxidizing agent kanina? The NADH and the FADH. Flavine adenine dinucleotide is converted to flavine adenine dinucleotide plus hydrogen. Okay? So, ano yung final product ng step number 6? Fumarate. FADH then enters the electron transport chain, the complex to transferring the electrons to ubiquinol, finally forming to ADPs. So, dito, dalawang ADP ang introduce niya because yung FADH mo enters the electron transport chain. So, there is a transport of electrons and two ADPs are formed. Okay? Next, second to the last step. Hydration. Kanina, dehydration. Removal of water plus dehydrogenation. Dito, hydration of fumarate to malate. Hydration meaning you add hydration, water. Water is added. So fumarate is reversibly hydrated to form the L-malate in the presence of enzyme fumarate hydratase. Ang enzyme hydratase. Hydratase siya, hydration meaning adding of water. Kung dehydration siya, removal of water. Okay? So, as reversible reaction, take note reversible, a formation of L-malate involves hydration, whereas formation of fumarate involves dehydration. Meaning, fumarate, hydration. Okay? Fumarate to malate, that is hydration. Next, malic to pumalic, dehydration. Because the process involved in step number 7 is reversible reaction. Okay? Did you get it? Paano? Okay? The recording should be played again and again para maintindihan ito. Take note, there is what we call between pumalic to malic, there is a transition state. So the enzyme involved is pumalase. So pumalic first is converted to anion or negative. Anion is negative, correct? Because of the OH and carboxyl, then converted to malic. This is now your transition state. So the enzyme is almost the same, pumalase and carbon. Okay? Final step. Dehydrogenation of L-malic to oxaloacetate, which is acted by L-malic dehydrogenase. What is the reaction? Dehydrogenase, please manaliyaw. Dehydrogenase, ano reaction?
Removal of hydrogen.
Dehydrogenase. Dehydrogenation. Removal of? Dehydrogenation. Genase, hydrogen. Ang hydration ng water, dehydration water. Hydration, addition of water. Okay? So this is reversible reaction, both L-malic reduction of NAD into NADH or removal of dalawang hydrogen. NAD to NADH. Okay? Oxaloacetate plus bond allows repetition of cycle. NADH bond participates in oxidative phosphorylation. This completes the cycle. Okay? So yung NADH bond participates in oxidation reaction or phosphorylation process. So to complete the cycle. Okay? So yung TCA, the final product is oxaloacetate. Okay? Go back to the summary. Summary tayo. Ito yung summary niya. Yan. So, first, try to see pyruvate. Okay na pyruvate nyo. Pyruvate is converted to acetyl coenzyme A. Okay? That is a condensation process. Then, yung acetyl coenzyme A mo, okay, is converted to citrate by citrate synthase enzyme. Okay? Or, your pyruvate is converted to oxaloacetate by pyruvate carboxylase. Okay? Sa kanan mo ito. Klaro. Stick pa. Stick. Hindi ka nasa. Ay, kumang TV. Dilan. Okay? Yan. Si pyruvate to acetyl coenzyme A, di ba the process is dehydrogenation? Or is condensation, di ba? Forming your acetyl coenzyme A. This is already your pre-step. Okay? Yung pyruvate mo, pwede siya mag-diretso kay oxaloacetate by carboxylation process. By pyruvate carboxylase. Basta carboxylase, carboxylation. Addition of carboxyl group. Okay? So, si oxaloacetate mo, pwede siya mag-convert into citrate by citrate synthase enzyme. Correct? So, first step, of course, yung citrate to cis-aconitate. Okay? There is dehydration process which is acted by aconitase enzyme. Okay? Step number ano ito? Aconitase, step number 2. 2 na. Step number 3, cis-aconitate is converted to D-isocitrate. There is hydration naman. Ito, basta water may atom plus, dehydration. Hydration forming D-isocitrate. Okay, this is your third step. D-isocitrate to alpha ketoglutarate. The fourth step, there is removal of
Hydrogen.
carboxyl group and acted by isocitrate dehydrogenase. So, dehydrogenation. Okay? Dalawang reaction ito. Decarboxylation, removal of a carboxyl group. Then your alpha ketobutyrate, step number 5, positional coenzyme A, again, dehydrogenation. Alpha ketobutyrate dehydrogenase enzyme. So NAD is converted to NADH. Then succinyl to succinate, step number 6. So this is what we call A. Yung GDP mo is converted to GDP. One phosphate group is utilized, acted by succinyl coenzyme synthase. Then step number 7, succinate to fumarate, dehydrogenation, succinate dehydrogenase. Then fumarate dehydration, acted by fumarase enzyme. Then malate to oxaloacetate by malate dehydrogenase. So this is a cycle. Okay? Next. So overall reaction, take note of citric acid cycle, acetyl coenzyme A, 3 NAD, 1 MAD, 1 ADP, 1 inorganic phosphate is equals to 2 carboxyl group, 3 NADH, 3 hydrogen, 1 NADH, and 1 ATP. Okay? In words, the equation is written as acetyl coenzyme A plus nicotinamide adenine dinucleotide plus tabine adenine dinucleotide plus your adenosine diphosphate plus phosphate equivalent to pyruvate plus water plus adenosine diphosphate plus nicotinamide adenine dinucleotide plus hydrogen ion. That is the overall reaction process. Okay? Next, break time na ng 5 minutes. Ito sa kitang laway ko. Okay? We have to finish everything, the cycle. It's a cycle. Ang ating na video is ganito. Okay? Core cycle tayo dito na. Start na. Okay? So, 5 minutes break. Okay? Ikaw na to. Ano pamili mo? Ha? Ano pamili mo? Si Bernasol ulit. Okay? We got to core cycle or lactic acid cycle. Okay? So, cycle in carbohydrate metabolism is a conversion of your glycogen to lactic acid. Okay? So, usually found in the muscle. Okay? Take note. The cycle in carbohydrate metabolism consisting of conversion of glycogen to lactic acid in the muscles. Then diffusion of lactic acid into the bloodstream carries into the liver and converted to glycogen. That is a core cycle. Tandaan nyo, carbohydrate, take note, is consisting of conversion of your glycogen to lactic acid in the muscles and diffusion of lactic acid in the red blood cells that is brought into the liver. Where in the liver it is converted to the glycogen. Okay? And the breakdown of liver glycogen to glucose, which is transported by the muscles to the bloodstream and reconverted to glycogen. Meaning, yung core cycle, glycogen is converted to lactic acid, okay, sa muscles, then the diffusion of lactic acid into the bloodstream, which is carried to the liver. Meaning, from the muscle to the RBC to the liver. Okay? Then, the liver is converted to glycogen again. Then, the breakdown of glycogen, which is transported to the muscles. Breakdown of glycogen is known to be glycogenolysis. Glycogen is converted to glucose again, or methionine. Okay? Picture ka. Okay? Next. Okay. So the reaction cascade sequence is as follows. So meaning cascade series. This is a series of reactions. So, take note, Cori cycle depends on the hormone known as epinephrine. Take note, epinephrine binds to the receptor. What is the receptor? Delta receptor. Delta receptor. So, epinephrine binds the receptor on the muscles. Once epinephrine binds to the receptor, okay, na sa Cori cycle, your API or epinephrine binds with delta receptor. Okay? Ito yung cell membrane na lagay natin yung cell. Okay? So once API or epinephrine binds with the beta receptor, the AC enzyme is activated. Take note. Adenylate cyclase in the cell membrane is stimulated or activated. Again, API binds to the beta receptor. Once API binds to the beta receptor, of course, there is a combination of epinephrine. API is epinephrine. Epinephrine receptor complex, which stimulate or activate your AC. So, ano yung function ng AC? AC, once activated sa AC, it converts ATP to CAM. Okay? Pharmacology ko, balik ko na. So, ATP is converted to CAM once AC is activated. Okay? The increase in CAM activates protein kinase enzyme. Take note. Once CAM is activated, or once CAM is formed, this inactive protein kinase becomes activated or become active protein kinase. Okay? Paano naging active si protein kinase ganun? Due to CAM. Increase in CAM level, yung inactive protein kinase will be converted to active protein kinase enzyme. Okay? This? Yes. This is 0. Okay? So, this means it is also allosteric control when enzyme is switched for an activity. So, this is switch on. Correct? Switch on siya. Kasi yung inactive naging active, that is switch on for activity. Right? Sino ang mag-switch on kay protein kinase? CAM. Ginagawa si CAM. ATP. Paano i-convert si CAM to ATP? Because of adenylate cyclase enzyme. Sa pharmacology, balik-balik ko na. Remember. Okay? Remember the time. Diaz disease becomes the walking pharmacology. Walking ka sa na. Ano ba nila? Eh, ibig sa Tuesday, siguro, walking Diaz na lang. Next. Protein kinase becomes causes phosphorylation process. Meaning, once active si protein kinase is a series of phosphorylase enzyme. So once phosphorylase enzyme is activated, that is already phosphorylation process, which activates the glucose 1. Once phosphorylation process happens, it will finally produce glucose 1 phosphate. Okay, glucose 1 phosphate. At the same time, enzymes are being activated for glycogen breakdown. Glycogen synthase enzyme must be inactive. So, glycogenesis must be switched off and glycogenolysis is switched on. So, kung switch off kami, meaning, kung switch off, production of glycogen. Kung switch on, breakdown of glycogenolysis. Okay? So, take note that glycogen synthase enzyme must be inactivated. Kung inactivated si synthase, kasi ito, ano na Understand? So, glycogen synthase enzyme. Okay? Ano ito sa glycogen synthase enzyme? Okay? This involves the glycogenesis process. And we have the glycogenolysis process. Okay? Kung switch off ito, switch off, meaning glycogenesis must be switched off yung synthase enzyme. So there is no production of glycogen. Kung switch on, there is a breakdown of glycogen to glucose. That's why there's production of your glycogen 6-phosphate. Okay? So dalawa naman tapos class ha. In step number 4, diba, protein kinase is activated by your messenger, the CAP. CAP came from your ATP. Diba? So, CAP now will activate protein kinase, right? So, in activation of your protein kinase, there is what we call phosphorylation process happens, right? Forming glucose 1-phosphate. At the same time, enzymes are being activated for glycogen breakdown, glycogen synthase. So, inactivate siya si glycogen synthase. Kung inactivate si glycogen synthase, that is glycogenesis. Switch off. Kung switch on siya, glycogenolysis, breakdown of glycogen to glucose. Okay? So take note, glycogen to glucose 6-phosphate, that is phosphorylation process. So enzymes is, glycogen synthase enzyme is switch on. Glycogenolysis, glycogen to glucose 6-phosphate, that is glycogenolysis. So once glycogen is converted to glucose 6-phosphate, switch on. Ito, switch on. Kung glycogenesis naman, glucose 6-phosphate to glycogen, inactive si glycogen synthase. Switch off. Switch on. Once glucose 6-phosphate is produced, that is already the beginning again of glycolysis process. Okay? So, glucose 6-phosphate is the final result of initial stimulation of epinephrine. Take note. Once epinephrine in Cori cycle, once epinephrine binds with the receptor, that leads to activate adenylate cyclase enzyme. Right? Si adenylate cyclase enzyme converts your ATP to CAP. Okay? Si CAP, yung nag-activate kay protein kinase. Activation of protein kinase leads to phosphorylation process. Then your glycogen is converted to glucose 6-phosphate by your glycogen synthase enzyme. That is switch on. Basta glycogenolysis is switch on. But glycogen or glucose 6-phosphate to glycogen, that's glycogenesis, your glycogen synthase enzyme is switch on. Okay? 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 If this happens in the muscles, then glycolysis pathway is the next sequence. Meaning, ito yung final product once epinephrine is binds with your adenylate cyclase enzyme during the Cori cycle. Glucose 6-phosphate, then follow the glycolysis process. Diba? Glucose 6-phosphate is converted again to fructose 1,6-phosphate, etc. na hasta sa pyruvate naman na. Okay? Next, the overall reaction, diba? This is Cori cycle. Glucose 6-phosphate during glycolysis will form pyruvic acid or pyruvate. Then, pyruvate is converted to lactic acid. This one. This is found in the RBC and transported into the liver cells. In the liver cells, lactic acid again is converted to pyruvate or lactic is plastic note. Pyruvate acid is also known as pyruvate. Lactic acid is also known as lactate. So, pyruvate to lactate, then lactate is being carried by RBC to the liver. In the liver, lactate is converted again to pyruvate. Other pyruvates will be converted to acetyl coenzyme A. Remember, pyruvate to acetyl coenzyme A that is needed in the citric acid cycle to produce ATP. This ATP is needed in gluconeogenesis process. Pyruvate to glucose 6-phosphate. Okay? Yung pyruvate to glucose 6-phosphate needs the ATP. Yung step 8 is considered gluconeogenesis. Therefore, 6-phosphate is converted to glycogen by your glycogen synthase enzyme. Okay? So there will be switch off. That is already glycogenesis. To break down ito ng glycogen, ito, glycogenolysis. Switch on na glycogen synthase enzyme. Remember, ito, glycogen, break down siya. Diba? Break down siya dito, maging glucose siya. Kung glucose 6-phosphate, then balik ko naman dito sa cycle. Glycogen, can be break down ng glucose 6-phosphate, glucose 6-phosphate to glucose 6-phosphate, then cycle again, balik ko naman. That is the Cori cycle. Okay, the purpose of that one, of course, we need energy to produce again glucose. Glucose is being utilized in the body. You know, as long there is glucose in our body, Cori cycle glycolysis is continuous. That is why humans will survive for 1 week without water because of the glucose deposit until it will be used up. Then that's the time of patay na. Why? There's no energy anymore. Diba? Isang araw, hindi ka maging tubig. May sirena, mabuhay ka pa, diba? Next day, mabuhay ka pa. Siguro mga 1 week, mabuhay pa. Because glucose, may energy pa. Kung wala ng glucose, wala na i-utilize na lawas. Patay ka na. Wala ka ng energy. Okay? Next, glycogenolysis. So, the glycogenesis. So, tapos na tayo sa the citric acid cycle. Ano sa final product sa citric acid cycle? Citric acid. Citric acid. Anong pinaka-final product, Malik? Citric acid cycle. The TCA cycle kanina. Ang pinaka-product niya. Malik, oxaloacetate. Okay, sorry. Malik, oxaloacetate. Dito lang kami nag-isip sa malik. Okay, malik, oxaloacetate. Okay? Dito, sa citric acid, sa Cori cycle, glucose 6-phosphate is the final, is the product, which is utilized in glycolysis. So, paano sa maging glycolysis, maging glucose 6-phosphate pyruvate, then to lactate, then carry to the blood, papuntang liver. Sa liver, i-utilize sa TCA cycle, producing ATP, then follow the gluconeogenesis process, forming glucose 6-phosphate, then to glycogenesis. To glycogen, mag-break down glycogen, pwede pabalik sa glucose 6-phosphate to glucose 6-phosphate, again, glycogen, switch on, switch off, balik naman sa glucose 6-phosphate, balik naman sa pyruvate to lactate, balik naman. That is a Cori cycle. Enjoy this? Okay? Let's go with the glycogenesis process. So, karon, natapos na. Na-breakdown na using glucose. Build up naman ang glycogen. Diba? Dito na tayo sa, go back to the Cori cycle again. Cori cycle. Na. No. Diba? Ito yung last step. Correct? Last step? Oh, we go with the last step. Glycogenesis. Genesis. In the Bible, that is the beginning. Production. Lysis. Glycogen is breakdown yan. Okay? So, glycogenesis is a process of glycogen synthesis in which glucose molecules are added to form glycogen of storage. Storage of glycogen in the liver. Okay? That is for the animals. Okay? cellulose plants. Next, the process is activated in the respiratory following the Cori cycle in the liver, also activated by insulin in response to low glucose level. Correct? Balik naman balik. Statement following ito. Following Cori cycle in the liver. Yan. Dito tayo ng liver, dito na tayo sa glycogenesis. Pasunod na class na ako lecture. Nakuha nyo? Glycolysis. Byproduct. Last product. Pyruvate. Tapos nag-gluconeogenesis. Product, glucose 6-phosphate. After gluconeogenesis, nag-PCA cycle tayo. The pyruvate in glycolysis is utilized forming oxaloacetate. Correct? From that oxaloacetate, balik dito tayo sa Cori cycle. Epinephrine, glucose 6-phosphate naman. Then the last step is glycogenesis. Then we are now in the glycogenesis. Kasunod, naging kapon mo, hasta sa ginggamin mo, hasta na siya naging glycogen. Okay? Next. So, steps in glycogenesis, glucose converted to glucose 6-phosphate by the action of glucokinase enzyme. Okay, ginawa na lang kayo. Okay, recording tayo. Or hexokinase, the conversion from ATP to ADP. There is a loss of ATP. Glucose 6-phosphate is converted to glucose 1-phosphate by action of phosphoglucosidase. Okay? Glucose 6-phosphate to glucose 1-phosphate. What is the reaction? Design mo na. Mutase transfer isomerase. Isomerase mo yan. Glucose 1-phosphate. Isomerase na hindi. Transfer mo na sa phosphate group. Okay? Passing through obligatory intermediate glucose 1,6-bis phosphate. Glucose 1-phosphate is converted to uridine diphosphate glucose by the action of enzyme uridine diphosphate glucose phosphorylase. Okay? Pyrophosphate is formed, which is later hydrolyzed by pyrophosphatase into phosphate group. So again, at first step, glucose is converted to glucose 6-phosphate, then glucose 6-phosphate to glucose 1-phosphate, then your glucose 1-phosphate is converted to UDP, uridine diphosphate. Okay, this is uridine. Okay, una-una, glucose to glucose 6-phosphate. To glucose 1-phosphate to uridine diphosphate glucose. Okay, couple of steps. Okay, then uridine diphosphate glucose. Ano next? Pyrophosphate. Okay. Next. The enzyme glycogenase is needed to create initial short glycogen chain. Meaning may glycogen enzyme. So, zero form na kasi ang glycogen is glucose na siya. So, mawala na sa initial short glycogen chain. Glycogen is homodimer. So, homodimer that is considered to be a protein. Has a tyrosine residue, each subunit serves as anchor of reducing end of glycogen. Meaning siya yung tapik. Okay, sa anchor end of glycogen. Reducing end of glycogen is ang pinakapunta kung saan ka-anchor. Initially, the 8-uridine diphosphate glucose molecule are added to each tyrosine residue by glycogen forming 1,4 linkage bond. So, amat-amat na, the enzyme glycogen mag-formalize sa gagmay na glycogen short chains. Okay? Meaning ito lang, si uridine diphosphate are added to each other by glycogen forming 1,4 linkage. Okay? Next. Once the chain of glucose monomer is formed, the glycogen synthase enzyme binds with the glycogen chain and adds uridine glucose to 4-hydroxyl group of the glucosyl residue, non-reducing end of glycogen chain forming 1,4 linkage. So, may branches na may glycogen branching enzyme also known as amino alpha 1,4 alpha 1,6 trans glycosylase enzyme, which transfer the chain onto the earlier part via 1,6 glycosidic bond, forming branches. So, which further addition of meaning of 1,4 glycosidic bond, matapik-tapik na siya. Sino nga tapik-tapik na? Siyempre yung glycogen branching enzyme. Di ba ko na ma-form na sa 1,4 linkage. Tapos na, matapik-tapik na siya by branching, branch na. So, ano ba is na, summary? Glucose 6-phosphate. Diba? To glucose 1-phosphate. Right? Yung pyrophosphate, hindi niya inorganic phosphate ko siya. Wala na siya raport. Okay? Ako na siya i-utilize to form glycogen. Ito, inorganic phosphate. PI na siya. Okay? So, ito, UTP or uridine triphosphate plus glucose 1-phosphate. So, nagkaroon ng phosphorylation process. Okay? So, glucose 1-phosphate to uridine diphosphate glucose. Okay? Diba? Ako na siya ang i-utilize, hindi si pyrophosphate. Right? Tanda. Glycogen, mayroon siyang tyrosine residue. Diba? Sa tyrosine residue, tanda nyo, dira naman tapik-tapik si uridine glucose diphosphate. Okay? So matapik na din. This is your glycogen, this is an enzyme. Mayroon siyang tyrosine residue. Dira matapik si uridine diglucose phosphate. Then, with the help of your enzyme glycogen synthase, uridine diglucose phosphate, uridine diphosphate, okay, will form now the branching. Wala pa branching. Wala pa ito pa. Mapon sila. Ano to? Short units. Kapag ano na chain. Ito. So, 1,4 linkage. Tandaan nyo ha. Si glycogen, siya yung tyrosine na mag-branch anay kay uridine diglucose. Paano? Mag-branch anay sa kay uridine diglucose. Kapit anay sa uridine diglucose ito. Pagkakit niya, okay, yung uridine diglucose, diba, UDP plus yung glycogen enzyme. Glycogen siya, with the help of glycogen synthase enzyme, it will form now the short chains. The short chains mo, it will undergo branching to the process of branching enzyme. Mag-form siya ng 1,6 bond. Further inundation at the non-reducing end. Wala kang reduce kasi kung reduce na hindi siya mag-form glycogen. By glycogen synthase enzyme taking 1,4 bond, further branching 1,6 bond will form glycogen. That is glycogenesis. Again, glucose 6-phosphate is converted to glucose 1-phosphate to uridine diglucose phosphate. Okay, or uridine diphosphate glucose by uridine diglucose phosphorylase enzyme. Yung pyrophosphate siya. Ang enzyme pyrophosphate, naging inorganic phosphate na siya. Wala siya ginagawa. Kasi wala siyang glucose. Siyempre, glycogen is glucose plus glucose. Wala pa kailangan niya si pyrophosphate, wala kaya glucose. So, ang i-utilize uridine diglucose, uridine diphosphate glucose. So, si glycogen an enzyme with a tyrosine residue, mabahin na si uridine glucose diphosphate. That is 1,4. Wala ka 1,4. Okay, wala ka 1,4 branch. Okay? Then, nagkaroon namin tawag natin uridine, glycogen, uridine diglucose complex yan. Kapit sa dito kay tyrosine because of the oxygen. Tandaan nyo si enzyme. Sige, kung enzyme siya, protein siya. Mayroon sa tyrosine residue, correct? Dito mag-branch, dito matapik si uridine phosphoglucose sa OH yung tyrosine. Okay? So, ina siya, complex na siya. Nga, uridine diphosphate glucose plus yung glycogenine enzyme, correct? So, another one, it will undergo enzymatic reaction with the help of glycogen synthase enzyme, forming now 1,4 bond together with your glycogenine. Right? So it undergoes branching, a branching enzyme to form 1,6 bond, further elongation at non-reducing end by glycogen synthase making 1,4, further branching to form glycogen. Okay? So sige na topic. Okay? After sa 1,4 bond, 1,6 bonds, further branching, form glycogen. Okay? That is your glycogen synthesis or glycogenesis. Okay? Yan. O, glucose 6-phosphate, glucose 1-phosphate, uridine glucose, no? Phosphorylase. Okay? Forming uracil phosphate glucose or uridine. Then your glycogenine. Di ba si glycogenine mo, kaya siyang tapik doon sa upward siya ng 1,4. Then, further branching, ito ng buwan niya. So, glycogenine mo, aralan na. What is the purpose of glycogen? That is the purpose of glycogen is to form. Siya yung linkage. Kay glucose, dira sa mga other glucose, aralan na. So, that is your glycogen. So, this is your structure of glucose, of glycogen. Glucose, plus glucose, plus glucose, plus glucose, ano? 1,6. Diba? 1,4. 1,4 na. Kasi si glycogenine plus yung uridine phosphate glucose. Din mali. May tyrosine. So, glycogenine, may tyrosine siya. Matapik sa kahit uridine phosphate glucose. Forming 1,4. 1,4 ito. Then, 1,6. Then, okay? Next. So, glycogenesis, main forms of biophosphorylation, glycogen synthase, and glycogen phosphorylase. Tanang dalawang enzyme. This is regulated by enzymes under the control hormonal. Okay? Third regulated factors. This is considered to be allosteric. What hormone? What hormone ka control? Epinephrine. What hormone? Epinephrine. Balik dito sa oocyte. Sino regulated by enzyme under control what hormone? Epinephrine. Which is allosteric system. Na allosteric mo siya? Switch off and switch on of your glycogen synthase enzyme. Okay? So, regulation of synthesis, epinephrine. ATP to CAP, dependent to kinase, then active and inactive. Ito kanina yung allosteric. Glycogen active. Glycogenolysis, diba? Glycogenesis. Inhibited. Inactive dito, then we have the protein kinase. CAP-dependent, active glycogen synthase. Okay? Kung active siya, glycogen synthase, active glycogenesis. Inactive glycogenesis. Okay? O glucose switch off. Inactive glycogen synthase, inactive ito. Inactive siya once may phosphorylation. Pakita kayo class, yung glycogen synthase, mayroon diba may tawag tayong switch on, switch off. Paano maging switch off siya? Dapat mayroong phosphorylation. Dugang. Kung active siya, there is no phosphorylation process. There is no phosphate allowed. Gusto nyo yung sa usa na kanila? Balik kita dito lang. Yan. Ayan sa slide. Napo-recycle. Ano yun? Phosphorylase. usually is glucose 6-phosphate. Okay? Next. Yan tayo. Glycogenolysis. Yan. Yan na matapos. Okay? Glycogenolysis, degradation of stored glycogen. So meaning in muscle, glycogen to glucose 6-phosphate glycolysis. Liver, glycogen, glucose 6-phosphate to glucose, bloodstream, bile cells, glycolysis. Sa muscle sa glycogen to glycolysis, glucose 6-phosphate, diretso lang. Okay? Glycogen to glucose 6-phosphate glycolysis na yun. Pero liver, glycogen, glucose 6-phosphate to glucose, bloodstream, glycolysis. Because the muscle cells mainly consume glucose molecules, whereas liver cells store glucose molecules. Okay? Glycogen degradations consists of 3 steps. Release of glucose 1-phosphate from glycogen. Release. Glycogenolysis. Remodeling of glycogen substrate to permit further degradation. Meaning, sa glycogenolysis, reverse na sa isang glycogenesis. Kasi sa glycogenesis mo, mag-form siya ng damo-damo na chain. Hindi naman, ma-degrade. Ang glycogen mo ma-degrade. Glycogenolysis, breakdown of glycogen. Glycogenesis, hindi na formation of glycogen. Okay? Conversion of glucose 1-phosphate to glucose 6-phosphate. Balik na sa glycogenesis, glucose 6-phosphate to glucose 1-phosphate. So, dito naman sa glycogenolysis, dapat mamalik siya. Glucose 1-phosphate to glucose 6-phosphate. Kasi glucose 6-phosphate, ano si next ni? Glycolysis na. Okay? Yan. Reaction number 1. Conversion of glucose 6-phosphate to glucose 1-phosphate. The enzyme is phosphoglucose. Catalyzing the shift of phosphate group 2 between carbon. So, from glucose 6-phosphate, glucose 1-phosphate to glucose 6-phosphate. Okay, reaction number 1. Nalito na niya glycogenesis, glycogenolysis. Reaction number 2. Okay. Glucose 1-phosphate is activated before addition of glycogen carbon. So energy is released by phosphorylase. Okay? The high energy compound, the UTP transfers the uridine triphosphate, uracil triphosphate or uridine triphosphate to uridine monophosphate to glucose 1-phosphate to give unity glucose and pyrophosphate. Diba? Glucose 1-phosphate, babalik siya to uridine diglucose phosphate. Next, ano tabo? Reaction number 3, glycogen synthase enzyme breaks the phosphate bond of uridine. Diba? Paano no? Sa ito, glycogenesis. Step number 3, yung glucose will be released in uridine diphosphate. Tama nyo? Kasi ang genolysis is breakdown. Meaning, glucose is released from 1,4 glycosidic bond with the end of glycogen. So we have uridine diglucose 1,4. 1,4. So dito, ito yung uridine diphosphate. Ito ang tanay na sila kanina. Dito sa glycogenolysis at glycogenesis. Ang 1,4 bond, si glucose mo, amat-amat na siya takas. Kasi ang glycogenolysis breakdown of your glycogen to glucose. Opposite sa ng glycogenesis. Makanya? So, reaction 1 and 2, glycogenolysis, glycogen is broken down to glucose by phosphorylases process. Glucose molecules are removed from the glycogen chain. Glucose molecules are phosphorylated by glycogen phosphorylase to yield glucose 1-phosphate. That is reaction number 1. Reaction number 2, in reaction hydrolysis, glycogen phosphorylase leaves 1,4 until only 1 glucose is left. So, ito yan sa reaction number 2. So, meaning, makakas si glucose from glucose 1,4 linkage. Debranching enzyme. Ano ganis may glycolysis? Branching enzyme. Kaya, debranching enzyme breaks the 1,6 glucosidic bond. Diba kakina sa glycogenesis may 1,6 bond? Dili, debranching yung kakso nila. Branches of glucose molecules can be hydrolyzed by reaction 1. O, reaction 1 mo. Ano? By phosphorylase enzyme. So meaning, debranching enzymes na yan. Sa glycogenesis, branching enzyme. Debranching meaning it will going to break the branch of the glycogen. Okay? So yan ang reaction. Glycogen. So glucose 1-phosphate. Glycogen with 1 glucose removed. Yan. Oh, excuse me. Once may phosphorylation, magkakastig. Ang isa. Phosphorylation. Glycogen phosphorylase. Magbasta phosphorylase yan eh. Phosphorylase, addition phosphate group. Once phosphorylase enzyme is used up, magkaroon na glucose 1-phosphate. Mas separate na siya direct sa glycogen. Next na naman, another na naman. Next na naman, another na naman. Okay? Yes. Glucose 1,6, that is branching. Glucose 6-phosphate niya, hindi niya ano, ang horario. Genolysis na kita. Ang una, glucose 6-phosphate to glucose 1-phosphate. 6-1. Ay. Napalitan ito. Step number 1. Step number 1. Ay, glycogenesis hindi. Glycogenesis yan. Ay, glycogenesis yan. Sorry, glycogenesis class. It's ulit na. Glycogenesis. Glycogenolysis kaya ayaw. Glycogenolysis ha. Glucose. It's got glycogenesis din kita. Glucose 6-phosphate. 1 to 6 kita. Okay? Isomerase. I-summarize ko kanina ang glycogenesis 3, ang glycogenesis 2, and glycogenesis 1. Sorry, glycogenolysis ha. Glycogenesis 2 kamakal ko kanina. Sorry, din. Okay, ano pa na naman sa gawing summarize lang. Reaction number 1, isomerization sa glycogenesis. Sorry ha. Glucose 6-phosphate to glucose 1-phosphate. Alright? Summarize na isang glycogenesis. Nag-jump po sa glycogenolysis already. Then, yung phosphoglucose enzyme, we're going to catalyze the shift of your phosphate group. Then, sa reaction number 2 ng glycogenesis, glucose 1-phosphate. Okay? So, there's what we call conversion to unity glucose, correct? Tama. Then, reaction number 3, yung unity glucose mo, okay, the break of phosphate group forming 1,4 branch. Sorry class, excuse me, correct. I-edit ko na ito parang glycogenesis na ito, summarize naman na yung reaction. Okay? Sobrang natin matasi kayo kung then, ikaw na glycogenolysis. Sa glycogenolysis, that is your phosphorylysis process. Glucose molecules are removed from glycogen chain. Okay, this is your glucose 1 to glucose 6-phosphate. Okay, so reaction number 2, glycogen phosphorylase brings 1,4-late until 1 glucose is left. Debranching enzyme. Once it glucosidic bond branches glucose molecules hydrolyzed by reaction 1. So, ganyan ang pagkabo sa glycogenolysis. Okay, glycogen phosphorylation process. I-add yung phosphate group, ma-separate ang isa. Glucose 1-phosphate, followed by 1 until separation. Next. Reaction number 3, isomerization of glucose 1-phosphate. Molecules are converted to glucose 1-phosphate to glucose 6-phosphate. 1, 2, 3, 4, 5, 6. Reaction number 3, glucose 1-phosphate to glucose 6-phosphate kasi si glucose 6-phosphate ito na siya i-process for glycolysis. Again, take note. Final product ng glycogenolysis, glucose 6-phosphate. The glucose 6-phosphate will enter now glycolysis process. Again, to correct glycogenolysis, the final product is glucose 6-phosphate. Okay? Di na rin si glucose 6-phosphate kay glucose 1-phosphate by isomerization process. Kaya isomerize siya. Okay? By phosphoglucosidase enzyme. So once glucose 6-phosphate is formed, glycolysis will follow. Okay? Yan, reaction number 4, glycolysis, or in the liver or kidney only, the glucose plus phosphate usually is transported in the blood. Right? Ito sa blood na. Blood naman siya, glucose. Hindi yan glycolysis. Pero kung glucose 6-phosphate is converted to glucose, di ba ano yan eh? Reaction number 1 of gluconeogenesis. Glucose 6-phosphate to glucose. Gluconeogenesis yan. Okay? So ito, found in the blood. It will be transported into the muscle by uptake of glucose transporter 4 again glycolysis naman. Okay? Balik-balik yan. Yung chemic pathway is usually, may pharmacology na kayo. Ito sa pharmacology ng class. Chemic pathway is aromatic synthesis, also known as chemic, or is a cyclohexene. Cyclitol, cyclohexane, carboxylic acid. Cyclohexene, hindi may double bond. Or cyclohexane. Mga cyclohexane walang double bond. Cyclitol, may OH. Remember, inorganic yan. Pero ito kasi discuss ito sa PICO. This was already in the biochemistry. Sa isa, nagbawa ng chemic. Lawig-lawig na. Okay? Chemic. So, chemic acid pathway. Precursors na. Take note. Aromatic amino acid. Methylene, tyrosine, tryptophan. Okay? Biosynthesis in bacteria, fungi, higher plants, animals, and human. Okay? Building blocks to form certain alkaloids, coumarin, propanes, starting point for tannins in plants, provide protection against microorganisms. After class, it will be discussed on your people. Gawin na people teacher will discuss na. Isa sa board exam ko siya. Okay? Chimic acid is the part some hydrolyzed about tannins. Okay? Mga tannins, speak ng tago pala. Kita yung tago? Mga kalungan sa mga rubber brain na tago. Rich in tannins na siya. Okay? So, 7 steps metabolic use of fungi, bacteria, algae, plants. So, biosynthesis of phenyl, tyrosine, and tryptophan. Okay? So, usually, ang chemically usually happens in this way class. Erythrose phosphate is converted to phenyl pyruvic acid, the PPA. Hindi makita PPA. It is the byproduct of the metabolism of your phenyl tryptophan. Diba? Phenylalanine. Phenylalanine to phenyl pyruvic acid, PPA, remember in tyrosine, phenylketonuria na pathway. Diba convert siya dito sa phenyl pyruvic acid? Then it will form, plus it will bring to erythrose 4-phosphate, forming 2-ketone 3-deoxy 7-phosphate glucoic acid to dihydroponic acid. Okay? So, the DHQ to 3-hydroxynic acid, 3-hydroxynic acid is dehydrated to 3-dehydroxynic acid by the enzyme 3-hydroxylase dehydration, which is reduced to chimic acid by enzyme chimic dehydrogenase. Ito yung product ng chimic acid. Okay, natawag nila ng enzyme. Actually, wala ko na question na nagwa. Okay, wala kang question na class. So, chimic acid is converted to chimic 3-phosphate to corysinic acid. Then, corysinic acid to prevenic acid to phenyl pyruvic acid to phenylalanine. or para-hydroxypyridic pyruvic acid to tyrosine. So this is reductive animation process. Okay. Ako wala na nagwa na class. Discuss ko na, gawin ko lang ng inyo na teacher nila magamit. So vitamins, this one. We have the water-soluble vitamins. Take ito. The B complex. B vitamin 1, 2, B1, B2, B3. We have vitamin acid. Vitamins methyl group. We have the polyphenol. Vitamins metabolic conversion of pyridoxine, pyridoxal, and pyridoxamine. And we have the vitamin C. You know water-soluble vitamins. Okay. Thiamine, this one is used. Signs and symptoms of beriberi, the all. Whole grain, mga meats, mayroong peas and pills, may mga thiamine yan. Beriberi, that is deficiency, hindi kung dugo ang thiamine mo, pwede magkaroon ng beriberi. Severe deficiency, mayroon siya. Primary areas where polished rice is primary food source includes dry skin, irritability, wet beriberi. Okay? Or we have the winter-Korsakoff syndrome associated with severe alcoholism. Okay? Severe alcoholism, kaya yun mo ang unang vitamin, thiamine. Okay? So, toxicities, contraindication, other notes, used as treatment, deficiency, commonly given alcoholics in ER. So, kung may mga alcoholic na excess of vitamin, one vitamin, B vitamin can cause deficiency in others. So, dapat alcoholics, tinatagahan na sa B complex. Okay? Yes, kasi kung dapat ang kawas mo, kawag din, ikaw Mrs. Tenan, ikaw Miss Chick, sino naman kawag din, hindi nung din. Okay, kung dapat nyo, yung dumong nyo na, vitamin, makasama mo sa Korsakoff syndrome. Okay? Yan. Complication of thiamine deficiency is known to be very. Okay? Hemoglobin. Okay? Food source. So, milk, cheese, meat, signs and symptoms, deficiency, kilosis, red lips, o pula lips din. O again, 60 ba again, pula lips man, kilosis ka. Anemia, yun pati. So, the hemoglobin usually used as combined with labing adenine nucleotide, yung reducing agent. Dahil na-combine si hemoglobin. Okay? That is your vitamin B2. B1, thiamine. B2, hemoglobin. So ano yung mga complications ng hemoglobin? Glossitis, inflammation of the tongue. Hindi glossitis, inflammation glossa. Tongue na yan, glossitis. Okay? Kilosis, inflammation of the lips. Kilosis. Stomatitis. Stomatitis, inflammation of ano? Stomatitis, mouth. Very good. Stomatitis, mouth. Glossitis, tongue. Kilosis, lips. May red lips ka. Duwag ka rin dito, kilosis. Okay? Dermatitis, syempre sa skin. Okay? Niacin. Okay? Niacin. So, yung source niya, ganyan. Pilagra. The rough skin. May deficiency ka, pilagra. The dry skin ka pala, gaspang skin mo tulang sa vitamin. Niacin. Okay? B3. Okay? So, ang B3 usually, itong bioskin, dito ka naman sa hand. Ano sa kabin? B2. Take note. Used as subsidizing agent. Vitamin B3, niacin binds with 9. Sa 5, NAD. Thiamine. Ano yung thiamine? Ay, hemoglobin. Sorry, hemoglobin ba? Dalawa. O, hemoglobin sa labin. Dito, B2, labin. B3, niacin. Okay? Ginagamit na siya as cofactor. Diba sa reaction may B2 na sa mga reaction enzymes. Okay? Biotin. Bio ka. Biotin, food source, ito yung mga intestinal bacteria. So may mga dermatitis, may deficiency, may muscle pain. Toxicities, chronic consumption of raw eggs. Sino kakawang sa itlog yan, wala kang pagpalaan. Wala kang luto na itlog. Mas mabayot ka, kailangan. Sobrang kabayot. Bayot. Chronic inflammatory bowel disease causes the deficiency. Meaning, chronic inflammatory bowel disease. Masagan, lahat naman siya pagkaling. Kami na... Next. Yan. So, food source ng pathogenic B5. Ubiquitous, meaning, something you can found everywhere. Easily destroyed by heating. Signs, symptoms, very rare, neuromuscular degeneration na. Toxicity, superlification, megadose, cause diarrhea, and water. So, B complex, B1. B1 is thiamine, B2 is niacin, B3 is B3 niacin, B2 glutamine. Pantothenic acid, coenzyme, biotin, carboxylation reaction, yung ginagamitan sa enzymatic reaction as cofactor sila. Vitamins ay used as cofactor. Thiamine and pyruvate dehydrogenase, triphosphate, globulin, B3, coenzyme, pantothenic, biotin, decarboxylase, tandaan na. Okay? B6, globulin, food source, whole grain milk, convulsive disorders, low level of gamma butyric acid, o GABA. So meaning, it is a neurotransmitter, management of neuropathic pain. Okay? So excess can lead to nerve dysfunction, loss of feelings in fingers, wala ang feelings in fingers mo. Legs, extra pyridoxine needed for isoniazid treatment of TB. Yan, nagamit yan. Okay? Isoniazid binds covalently to pyridoxal phosphate of pyridoxine, meaning to prevent isoniazid toxicity na combine si pyridoxine. Abante, excuse me, para hindi ka masubrang sa isoniazid, i-treatment sa TB, pinacombine ang biotin B6 pyridoxine. Okay? Ano matapos? Pyridoxine, o maganda. Nag-routine pa. Ano oras na class? Alas 12 na? Dali na lang yung class. Dali na lang yun. Dali na lang yun. Dali na lang yun. Dali na lang yun. Huwag na routine pa. Luto mo ng computer mo. B6 catalyzes the reaction of pyrophosphate to Schiff's base. So, transamination, take note, catalyze the reaction of oxaloacetate plus glutamate, aspartate plus ketoglutarate. Remember this one. Now, nandun man rin sa may protein nila. Oxaloacetate plus glutamate will form aspartate plus ketoglutarate. Deamination, serine pyruvate, decarboxylase, D-glutamate, condensation, glycine plus succinyl coenzyme will form gamma aminobutyric acid. So, ginagamitan yan vitamin B6. Okay? Next, folic acid. Food source, cooking oil, hemolytic anemia. So, kung kulang sa folic acid na anemia ka, that's why mga pregnant women nag-acid sa folic acid because they are prone to anemic. Okay? Mabusog na ng mga mana after 20 years. Constipation, critically pregnant women, take note, megadose can interfere with zinc absorption, may interfere with anti-epileptic drug mga pentobarbital or pentobarbital. So hindi siya pwede, these vitamins do not give together with anti-epilepsy. May mga epileptic drug na maintain sa mga pentobarbitals or pentobarbitals, so it is not given. Okay? May mga anti-epileptic, may mga epilepsy na maintain sa anti-epileptic drug. Here, it will interfere with anti-epileptic drug, so meaning si anti-epileptic drug, hindi siya maging effective. Okay? Next, B12, B12, vitamin B12, synthesized by microorganisms. So if there's deficiency, pernicious anemia, gapon, neoplastic anemia, neurologic dysfunctions, then toxicities, substantial stores of B12 are found in the body that may develop deficiency for years. Caution patients having gastrointestinal surgery. Okay? Vitamin C, yan. Food source for distribution, citrus fruits. Sino nagamit ng vitamin C? Scurvy. Deficiency meaning lower amount. Result in smoking gums, loose skin, and bleeding. Cause oxidation, presence of free radicals. Can be toxic with hemodialysis patient or iron storage diseases. Ascorbate is metabolized to oxalate which can be insoluble precipitates in calcium ions. So may mga calcium kidney stones and calciuria. Sobrahan na sini. So dapat hindi na mag-take sini. Okay? Dapat ascorbate pala, ascorbate. Sodium ascorbate is a base. Ascorbic acid is acid. Diba? Nakatake ko mga sodium ascorbate. Sodium ascorbate is not really helpful na naman. Pwede ka na i-lower, i-higher ang pH at yung stomach, hindi na ma-digest na yun. Pinandaling sodium ascorbate now, ascorbic acid is very important. Salt na lang na siya, actually. Pero yung take of sodium ascorbate, i-interview na sa ito na GIT. Okay, next. Fat soluble vitamins na added. Vitamin A. So, low fats, symptoms, night blindness, no growth in children, overdose and result of dry skin. Defects with liver damage. Vitamin A derivatives of isolate activate and cause birth defects once sobra. D. Ayun D. Distribution. Folic acid phenol. High cholesterol. Okay. Food source distribution. Vitamin D is hormone, regulates the calcium and phosphorus. Okay? Rickets in children in osteomalacia, kulang ka. Toxicities, calcium deposit in the heart, hypertension. E, food source, yan. Function reacts with neutralize, usually used as antioxidant, vitamin E. Okay? K, ang K is used as excess bleeding and bleeding gums. Phytonadione, ang phytonadione kasi nagamit as anticoagulant. That's why galing kung may mga labor, mga women, in-inject ang vitamin K to prevent bleeding. Okay? Kung deficiency, kulang ka sa vitamin K, magkaroon ka ng bleeding. Ginamit ang vitamin K to prevent bleeding. So, keynotes, importante ito. Lumabas dyan. So, aspartame artificial sweeteners. Mati ito yung keynotes. Insulin, hormone, known as abundance. Regulator of blood sugar, insulin. Diba siya yung facilitate sa glucose transporter 4. Vasopressin, antidiuretic hormone, known as oligopeptide. Glucagon, hormone of starvation. Ang glucagon plus, opposite sa effect ng insulin. Si insulin, usually nagpapalower na glucose. Si glucagon, nagpapa-raise ng glucose. Magnesium, cofactor in many enzymatic reactions. Diba, common si magnesium ion sa mga reactions. Okay? Okay, next. RBC. RBC are not found in walang mitochondria. Okay? And not capable of tricarboxylic acid cycle. Anong aras sa tricarboxylic acid cycle? We can be found that one. Ang RBC, wala siya mitochondria. So, hindi siya pwede sa tricarboxylic acid cycle. Yes, mitochondria. Hindi wala pa mitochondria RBC. So, RBC is not involved in TCA cycle. Tandaan nyo, ay wala sa mitochondria. Okay? TCA cycle happens in the liver. Which is, because the liver besides mitochondria man. 12 ATP is produced if every acetyl coenzyme A oxidized. Ito, 3 ATP is produced in the reduction of NAD to NADH. 2 ATP basta NADH2, NAD tatlo. 2 ATP for Krebs cycle, duwalan sa Krebs cycle na nakita ka. 24 ATP maximum yield. Kabinugan sa Krebs cycle, 24. Okay? For phosphorylation na yan, 2 ATPs. Pero sa overall na Krebs cycle, 24 ATPs. Okay? Take note. Yan yun ha. Diseases, marked Ardell disease, this one is glycogen storage disease. Rare in mutant which body is not, cannot break down glycogen. So, what is the defect? Kung hindi ma-break down, ano na enzyme ang defect? Debranching. Breakdown ng glycogen. So, marked Ardell disease. So, mayroon siya deficiency in enzyme, debranching enzyme. Her's disease, glycogen storage disease deficiency in muscle, phosphorylase. Hindi mo lang phosphorylation process. Anderson. Basta GSD gani, glucose, glycogen storage disease. Type 4, deficiency in glycogen branching enzymes cause inborn error. Branching glycogenesis. Debranching enzymes, glycogenolysis. Tay-Sachs, ito, lysosomal storage disease. Magmula ka sa lysosome sa loob ng Tay-Sachs disease. Okay? Budd-Gertis disease, also called type 1 glycogen storage disease, deficiency glucose 6-phosphate. Cori type 1A, glucose 6-phosphatase translocase enzyme. Diba? Okay. Wala na. So, class take note from last. Ay makahuli kita sa inyo. Kung picture ka na eh. Okay. Isend po. Tingnan natin kung okay. Mag-ibot na ako ng laptop ko. 200. Napindot-pindot na. Okay. So, thank you very much for coming.